Okay, so problem number 2, if you're looking at this guy, obviously you would like to assume it's a rectangle. It looks very much like a rectangle, but we have to prove it. You can't just call it a rectangle. So we need to make sure that the opposite sides are congruent and that these two sides are different than these two sides. We want to prove these are 90-degree angles, and we want to prove that the opposite sides are parallel as well. So end to end, let's count our slopes. So rise 2, run 4. So rise 2, run 4. It's a positive line, so that's 1/2. This is also 1, 2, 3, 4. Rise 2, 1, 4. I'm sorry, rise 2, run 4. Positive line as well. So MN is 1/2. And then so is PO. Is also 1/2. So this proves parallel because they're the same slope. So we know we can mark this of that nature. Then to do the other side, so 1, 2, rise 2, run 1. So rise 2, run 1. It is a negative line because it's decreasing. So NO is rise 2, run 1, negative. And then we also have MP, which is rise 2, run 1, which again means the two slopes are the same. So these are parallel. And hopefully at this point, especially if you're using Pythagorean theorem to do your distance, you know that these are going to have the same distance because their slopes are the same on opposite sides. So opposite sides are going to have the same distance. And this is different enough to not be this. So they're not going to be the same length. So as far as your length stuff. But again, you have to prove it. So we have, if I'm looking at MN first, so I have a rise 2. So 2 squared, or one side of the triangle is 2, plus 4 squared equals C squared. So again, that's looking at this as if it was a right triangle. And we're solving for the hypotenuse over here. So it's 4 plus 16 equals C squared. That's going to give us 20. Give us a nasty number. So ultimately, you can just say it is the square root of 20, and that's fine. PO has the same numbers, the 2 and the 4 again. So we're going to have the square root of 20 on both sides. So we know that they're equal distance and length, and the length would be square root of 20. If you want to make it a decimal, just round to the nearest 100. So the third spot out, and for accuracy as normal. And if it doesn't round well, then obviously go to your best spot, because that's again one of those things that's going to be depending on the teacher, the test maker, or the worksheet. This one does round 5 to the 100, so 4.472. But this is more likely how you're going to see the answer. If it takes a root and it's a square root of 25 and it's a nice neat number, then they usually use the real number. If it's a decimal, more times than not, but not always, they leave it as a square root of 20 because you're just proving that they're the same length, not necessarily the discussion of how actually long it is in these problems. So then we're going to do the same thing for MN and MO and MP. We have a slope of -2/1. So as far as our triangle goes, we don't need the negative part because we just need to know how high is the triangle. So one leg is 2 and the other leg is 1. So it's going to be 4 plus 1, which gives me 5. And this side's C squared. Sorry, trying to stick to the same notation. To get C by itself, you're going to square root, which means the length is a square root of 5. Again, square root of 5 is not going to give you a great answer, like a nice, neat non-decimal. But for the sake of discussing it, it's going to be 2.236. Again, more than likely you're going to see it the square root of 5. And because their slopes are the same, both of them are going to have the same length. So you know these two are the same length and these two are the same length, but the adjacent sides are not the same length. Now, the only other thing you're missing for rectangle is to prove that all 4 corners are 90 degrees. And so that would be perpendicular. So you want to prove this is a right angle. And the way you do that is opposite reciprocal slopes. You do the opposite. So one should be positive, one should be negative. And reciprocal, one, they should flip. So if I take NO, which is a -2/1, and PO, which is 1/2, one's negative, one's positive, and they flipped. The video you watched also said that if I was to multiply this out, so that would give me -2 over +2, which gives me a -1. That's how you can check that they're reciprocal as well. So if the switches sign and flip doesn't make sense to you, multiply the two slopes together, and you should get a -1. So this line of your work, this over here, proves it a parallelogram, which is very vague. That's like me calling you a student and not by your name. So parallelogram, and then the opposite reciprocal 90-degree angles on the inside is what proves it to be a rectangle. So this is a rectangle.